In this lesson, we're going to discuss how to factor polynomials with two terms. There are two different types of problems that you will see in this lesson. The first of all is if it's two terms and they are squares. So for example, this is the formula for that. We have our two terms and it has to be the difference of two squares. If this is a positive sign with squares, we will not be able to use this formula. So in this case right here, as we recognize in the first example, here are two terms and we do have perfect squares for the first term and for the second term. And so we can go ahead and open the parentheses. And you need to ask this question, what times what gives us 4y squared? Well, in this case, it's 2y. The minus sign tells us that we're going to have opposite signs. And then we ask the question, what times what provides us 81, which would be 9 times 9. And at this point, we can see that there's no other factoring that can be done. We could have checked first to see, is there anything that we could have factored out first? We could not have. It would also be evident in the second step if we could have. So this would be our final answer as the factors. If we wanted to check this, we could actually use the FOIL method and we would come out with the original problem. In the second example here, we know that we don't have a perfect square in 12, but if you look at both terms and we have a minus sign, we need to check those things first. We realize that we can factor out a 3 to begin with, and we take a 3 out, we're left with 4 because 3 divides in 12 4 times minus a squared, and if we distribute we have the same thing. This is not our final answer because we still have two squares, we have a minus, and we have perfect squares. So in this case, we can open our parentheses. 2 times 2 is 4. This tells us that we have opposite signs. A times A is A squared, and we do have to bring the 3 down because if we folded this and distributed 3, we would end up with our original problem, and that's as far as it can be factored. So when the instructions say to factor, it means factor completely. Now, the other type of problem that you'll see in this lesson still is if there's two terms, but it will be of the problems if they are cubes, not squares. This can also have a positive sign or a negative sign in between the two terms. If it is a plus sign, addition sign, then we're going to use that first formula. If it's a negative sign, we use the second formula, looking at the first sign that's in the first set of parentheses. So in this first case, I would write the formula down that I'm going to use. Because there is a plus sign, I'm going to use the formula a plus b times a squared minus ab plus b squared. The more you write the formula down, the easier it is to remember. The next thing that I'm going to do is out here to the side, I'm going to do my scratch work. I'm going to write down what a and b actually are. Now a comes from the first term, but it is not the first term. It's not x cubed. It is the cube root of that. So you ask yourself, what times what gives you x cubed, which would be x. Same thing for the second term. What times what gives you 8, has to be the same number, which would be 2 in this case. After that's taken care of, then what we're going to do is substitute into the formula. So we're going to substitute our a, which is actually x, plus b, which is actually 2. Now in the second set of parentheses, you have to actually take care of some things as far as if you're going to have a squared, that means you're going to say x times x. You're going to have to square that x, which is x squared. Bring down the minus sign. This a times a and b together like this means multiply, so we're going to say a times b. Well, x times 2 is 2x. Plus b squared, we have to square the b, which 2 squared is going to give us positive 4. Now once we use this formula, that's as far as it can be factored. It will not be able to factor anymore. So that would be our final answer. And if we wanted to check this, we could multiply all of this together and get our original problem. If we have a minus sign in between, we're going to use that bottom formula. So we're going to use a minus b times a squared plus ab plus b squared. And again, I'm going to write down my a and b. A is going to be y times y, which is y cubed. B, do not bring the negative sign over here. The formula takes care of the negative sign. So you ask yourself, what times what gives us 64, which would be 4. All we do is plug this in. A is going to be y minus b, which is 4. We're going to square the a, so y times y is y squared, plus a times b, y times 4, which is 4y, plus b squared. 4 squared is going to give us 16. Final answer. And of course, if there's anything that we can take out to begin with, we would. That would be on all types of factoring. Now this goes back to the square terms. We realize we have a square, so we're not going to be able to use our cube formulas. In this case right here, we have perfect squares. This is just an unusual case that I wanted to point out. We have the minus sign, the different signs, so I'm going to go ahead and open up my parentheses. And the question is, this being the first term, what times what gives us x plus 1 squared, which would be x plus 1. X plus 1 times x plus 1 is x plus 1 squared. This minus sign says you're going to have opposite signs, and then we're going to say 3 times 3 gives us 9. But we're not going to be able to leave our answer like this because we have to have simplified answers. In this case, we can add the 1 and the 3 together, so we're going to end up with x plus 4, and then x, 1 minus 3 gives us negative 2. And that would be our final answer.